Good morning, doctor. So we are group 12 and we are the last group. So the product that we choose is electric kettle. So these are our group members. Next. Okay, so this is the product structure. So we choose the electric kettle, and the component that to make the electric kettle are tray set, heating element, handle, spoke, lid, main body, and packaging material. Next. So the demand that we forecast is 54,000 per year. So it's expected to grow by 2,000 per year. So from there, we make the aggregate plan and master production schedule for the first 3 months, which is January, February, and March. Next. So this is the process flow to make an electric kettle. So from here, we know that the assembly process is the bottleneck of this whole process. So from that process, we know that we can do the capacity analysis, which is 20 minutes per unit is the bottleneck station, and we can also do the bottleneck analysis. So in order to achieve the demand, which is 54,000 per year, we need at least 7 production lines to make it. So the number of workers that we require is 140 workers for the entire company.
So next this is the master production schedule for electric kettle. As you can see, this is the schedule for 3 months. For each month, we have highlighted using different color, and the sales of these are expected to be different for each day. For example, in the 6 and 7 day, because it is weekend, the sales is higher. So this applies to the whole period. Next is the bills of material. As you can see, there are three levels: level 0, 1, and 2. So from level 2 is the raw materials. We make it into level 1 process material, and finally we assemble it to become level 0 electric kettle. Next is the product specifications of the electric kettle, which shows the amount of ingredients and materials needed to produce one electric kettle in table 3. So in table 4, the materials are required for 500 electric kettles are multiplied by 500. In table 5, there's the lead time for electric kettle components. It can be seen that only handle takes 2 weeks to come. Other than that, it only takes 1 week. Next is the time phase product structure. In order to produce one electric kettle, we need to order a handle 2 weeks before and other raw materials 1 week before. Next, we take 40 minutes to produce the kettle. For the net requirement plan, we use the number of items we needed and deduct the time by the lead time. So as you can see, if we want the item on week 3, we need to buy the handle on week 1.
My name is Muhammad Firdaus, and I will present about project management. This is our Gantt chart of factory setup. Okay, this table shows the duration for each activity in factory setup. Okay, location. Our factory is placed roughly equidistant between our suppliers and our customers to minimize shipping and distribution times. We take 1 month to decide where we want to place our factory. Okay, this is our factory layout. Okay, and this is the area of processing. Okay, this is our machining installation picture. Cutting steel machine, main body welding machine, pressure casting machine, polishing machine, water hole punching machine, spot welding machine, cutting heating plate machine, heat pipe welding machine, cutting spot machine, die casting spot machine, and also cutting steel lid machine. Okay, for pilot production run, our company will launch a very small production run to be made in exactly the same conditions as mass production. If something totally fails, the worst case is that few pieces may have to be disposed. Okay, we will recruit 140 production workers because we need 7 production lines in our company, where each line requires 20 production workers. Only 2 workers may be needed to control certain machine. Okay, basically, our new production workers will undergo 1 month of training and they will be observed by their supervisors. Okay, for our first batch production is steel main body. It is because it must be done before processing the other parts. Okay, for quality inspection and approval from local authorities, there are three types of inspection: running test, stability test, and also internal check for workmanship. Okay, common mass production. This production will lower the time of our workers spend on each individual product.
Next, we're doing the AON analysis to determine the critical path. We assume the time required for each activity in the process, manufacture the electric kettle. After that, we construct the AON network, and through the analysis, we can determine the critical path, connect to the activity A, K, L, M, N, O, P, Q, R, and S. After that, we also can determine the early start, early finish, later start, later finish, and critical path, and tabulate the result in the table. Based on the AON and network constructed, the total manufacturing time for one unit of electric kettle is 40 minutes. The ES, EF, LS, and LF are determined and tabulated in table. The critical activities determined are A, K, L, M, N, O, P, Q, R, and S. After that, we also can construct a Gantt chart to help us monitor the manufacturing process well, using ES, EF, and LS, LF. Next, we're also doing the project crashing to shortening the duration of project. Based on the maximum crash time, crash cost assumed, we're able to crash the project duration from 40 minutes to 25 minutes, 35 minutes, and the total crashing cost can be calculated is 34 cents per minute. By assuming the factory working 12 hours per day and 300 days per year, total crashing cost per year required is 73,440. After crashing, we managed to shorten the project completion time to 35 minutes. And this is the WBS work breakdown structure. And we can see that in level 1 consists of cutting process, casting process, polishing, welding, assembly, testing, and packaging. And in each process consists of elements. As you can see, cutting process consists of steel main body, steel heating plate, steel spot, inner steel lip. Casting process consists of pressure casting on steel main body, die casting spot, while polishing consists of first stage and second stage. Welding, we need to welding on heat pipe to heating and welding the spot. Next, we also estimate the time for every activity in electric kettle manufacture process. We determine that the total variance is 2.2242 and standard deviation is 1.49 minute.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Firdaus bin Muhammad Sabri. So I will present about the big event, rate of return analysis and engineering economic analysis. So this is the big event analysis, and this is the data collection that we assume for the operation time of factory and also for the cost required for factory operation. And for the data that we assume early, we can know the fixed cost, variable cost, total cost, and also for the profit that company can get. And for the monthly profit, company can get up to 90,500 ringgit. And this is the break-even chart. And this is the example of the situation and the data we collect as stated in the table, which is the expenditure and income of the project. And let's say to start the business, our company need to make a loan for a bank to cover the investment. So the bank was offered a loan about 500,000, and the company was agreed to make a loan from that bank with the compounded growth rate at 5% for 10 years. And this is the cash flow diagram that we get based on the situation we assume earlier. First, we calculate for the annual costs. We use the PF factor, and then we calculate for the upgrading cost, which is we use the PF factor. Also, we calculate for the revenue cost, which is we find the P prime first, then we use PF factor to get the P at year 0. After that, we calculate all of the P total at year 0, and then we can find the F using FP factor. Let's say that company gets sponsorship from non-government organization NGO with total amount of 2 million ringgit to start the business. So we need to find the new P total at year 0, and after that we can get rate of return I, which is we calculate we get 20%, which is 20% is more higher than the interest rate that given by the bank, which is 5%.
So for the discussion, we select electric kettle because there will always be demand throughout the year, and we won't have like a few year or a few months with our equipments closed. To remain competitive, we decided that we'll go with product quality instead of price. Besides that, the knowledge we learn in the industrial engineering subject is found to be very helpful to start a business like this, such as the knowledge such as procurement, financial planning, and so on help us to determine the risks and rewards we have to face throughout this project.
In conclusion, we have used many industrial engineering tools to complete this project, which are break-even analysis, capacity analysis, AON diagram, and cash flow diagram. At the first, we assume that the demand of the electric kettle is 24,000 per year and expected to grow by 2,000 per year. Therefore, the expected demand of kettle will be 64,000 per year over a period of 5 years. From the process flow of manufacture process of it, we determined that the bottleneck station is assembly station because it took 20 minutes per unit to complete. Through capacity analysis, we can conclude that the hourly capacity is 3 kettles. We can add an addition assembly station to the bottleneck parallel to it to increase the efficiency of it. The hourly capacity can be increased to 6 kettles. Gantt chart and NON network are useful tools for us to determine critical path. Through the project crashing, we needed crashing cost total is 73,440 if we intend to reduce the project completion time from 40 minutes to 35 minutes. Besides, we also analyzed the economic feasibility of the electric kettle using break-even analysis and engineering economy analysis. The break-even analysis determines the break-even point and profit of the company. The cash flow diagram can help us visualize the present value and future value of the product over a 10 years period. The rate of return of the electric kettle is 20% annually. Therefore, we can conclude that the electric kettle is economically visible to the market and able to make profit to the company. In a nutshell, we learned that the importance of industrial engineering in managing the project and business. With specialized knowledge, industrial engineers able to improve the efficiency of process to eliminate the wastefulness of resource. Operation management, which includes financing, production, quality control, and marketing, are key elements that create the intrinsic values of a product and or service. In short, the objectives of this project are achieved successfully with great team working among members. That's all for my presentation. Thank you.